All right, let's dig into applications of alcohols. Methanol is a very important industrial chemical. More than 1 billion gallons are produced and used every year. Methanol is also the smallest alcohol that we can have. Okay. It has a formula of CH3OH, so it is the simplest alcohol that can possibly exist. We also sometimes refer to methanol as wood alcohol because the principal source for many years was the distillation of wood. Today, it's synthetically prepared in large quantities by reacting hydrogen gas with carbon monoxide. The industrial importance of methanol is due to its oxidation product, formaldehyde, which you saw previously, which is a major starting material for the production of plastics. Methanol is also used as a fuel in Indy-style racing cars, and it's still used today in other forms of racing. I would say another place that you might see methanol being used as a fuel is if you've ever made fondue. The fondue fuel that you buy at the grocery store is methanol. It burns with a very clean flame, very hot, but very clean. Now, methanol is highly toxic and causes permanent blindness if you were to consume it. Deaths and injuries have resulted as a consequence of mistakenly substituting methanol for ethanol in alcoholic beverages, such as in homemade illicit moonshine. Now, ethanol or ethyl alcohol, and you can see ethanol is here, and you can actually see the formula of ethanol is shown right here, CH3CH2OH. Ethanol is probably the most familiar alcohol because it's the active ingredient in alcoholic beverages. It's the alcohol that causes intoxication. It's also used in pharmaceuticals as a solvent and in aftershave lotions as an antiseptic and skin softener. It is an important industrial solvent as well. Ethanol has also become an emerging additive or even alternative to gasoline as a fuel. You notice that if you go to the gasoline pumps nowadays, they pretty much all say that there's ethanol added to them. In fact, you usually have to go to a special gas station if you want to find gasoline that doesn't have ethanol in it. Now, most ethanol is produced industrially on a large scale by the hydration of ethylene obtained from petroleum. And you can see that reaction, it's shown in your textbook. Ethanol for beverages and increasingly Ethanol for beverages and increasingly for use in fuel is produced by the yeast fermentation of carbohydrates such as sugars, starch, and cellulose. For example, a common method is the fermentation of glucose, and you see that reaction right here. We take glucose in the presence of yeast, and it yields ethanol and CO2, and that's why alcoholic beverages are carbonated. The 2-propanol that I drew in the upper right-hand corner here, also known as isopropyl alcohol, is the main component of rubbing alcohol and acts as an astringent on the skin. It causes the tissues to contract, which hardens the skin and limits secretions. Its rapid evaporation from the skin also lowers or cools your skin, which has a relieving effect. It's used as an antiseptic in 70% solution. So if you go and buy rubbing alcohol, you'll even see it says 70% on the bottle. Isopropyl alcohol or 2-propanol is toxic and should not be taken internally. So if you knew somebody who said, "Oh, rubbing alcohol, that's an alcohol, maybe I should consume that." Bad idea. Okay, it's highly toxic. Now, alcohols are very important biologically because the alcohol functional group occurs in a variety of compounds associated with biological system. For example, sugars, carbohydrates, contain several hydroxy groups, and starch and cellulose contain several thousand of hydroxy groups. And we're going to see that later on in chapter 11. The structures and uses of some common alcohols are shown in this table right here. So we have methanol, which can be used as a solvent. It's also used as a fuel, like I said. It's also used to make formaldehyde. Then we have ethanol. Like I told you, ethanol is the alcohol in alcoholic beverages. It's also used as a solvent in chemistry. It's also used as an additive to gasoline. Then we have 2-propanol or isopropyl alcohol, rubbing alcohol, which is again also used as a solvent. You see that most of them are used as solvents. Then we have 1-butanol, which can be used as a solvent. It's also found in hydraulic fluid. Then we have ethylene glycol or 1,2-ethane diol. So ethylene glycol is found in automobile antifreeze. Then we have 1,2-propanediol or propylene glycol, which is found in things like lotions. It causes them to be creamy. It's also found in foods, and it's also found in antifreeze. So antifreeze, if it didn't have a bittering agent, would actually be sweet. But anyhow, that's a topic for another conversation. Anyhow, then we have glycerol or 1,2,3 propane triol. So you can see that it's known by the names glycerol, glycerin, 1,2,3 propane triol, and it is a moisturizer in foods. It's found in cosmetics as well. And glycerol, I think I told you this in a previous video, it comes from the hydrolysis of animal fat. And then the last one is menthol. And I'm sure some of you have heard of menthol before. It's found in cigarettes, or menthol cigarettes anyway. Anyhow, it's also found in things like cough drops and shaving lotions and probably some kind of gums and things like that. Now, on the subject of phenol that I have in the circle here, in dilute solutions, phenol is used as an antiseptic and disinfectant. Joseph Lister, who was a surgeon, introduced the use of phenol as a hospital antiseptic in the late 1800s. Before that time, antiseptics had not been used, and very few patients survived even minor surgeries because of postoperative infections. Boy, I wouldn't have wanted to be around in those days. Anyhow, today there are effective derivatives used as antiseptics instead of phenol that are less irritating to the skin. Two such compounds are 4-chloro-3,5-dimethylphenol and 4-hexylresorcinol that you see here on the slide. A couple other derivatives of phenol are orthophenylphenol, and I don't have the structure of that here, but orthophenylphenol would just be a phenol. It would just be a phenol that has a phenyl in the ortho position. So like that, orthophenylphenol. And then also 2-benzyl-4-chlorophenol, which are shown here, are ingredients in Lysol, which is a disinfectant for, you might use it to disinfect your kitchen countertops or something like that. It's used to disinfect furniture and hospitals and all that kind of stuff. Anyhow, other important phenols act as what we call antioxidants by interfering with oxidizing reactions. These phenols are useful in protecting foods from spoilage and a variety of other materials from unwanted reactions. Butylated hydroxyanisole, or BHA, and butylated hydroxytoluene, or BHT, are widely used as antioxidants in gasoline, lubricating oils, rubber, and some foods and packaging materials for foods that might turn rancid. In food or containers used to package food, the amount of these antioxidants is limited to 200 parts per million or 0.02% based on the fat or oil content of the food. Notice that industrial nomenclature for the compounds, if you look at them in the textbook, they don't follow the IUPAC rules. And you can see the name here, okay? You can see that it doesn't exactly follow the IUPAC rules.